We will now see an interesting effect called the compressor. It is the main effect to control loudness of the audio. If you can't use the compressor effect well, you can't get top-quality audio through audio processing. The compressor effect is complex, but it is very important for controlling audio loudness. If you go to the effects menu, you'll see there are several different ways to apply compression. You will see options such as dynamics, dynamic processing, multi-band compressor, single-band compressor, and a couple more. All of these are methods of compression, and they each have their own use cases. But for this lesson, we're going to focus on the simplest one so you can clearly understand what compression does before experimenting with more advanced variations. You may feel it is a bit early for such complex topics, but trust me, it makes the rest of the learning easier. Because it is one of the crucial effects to achieve proper loudness of the audio. When you have properly loud audio, it becomes easier to identify other issues and fix them. Most people use the compressor incorrectly because of its complex nature. However, once you understand how it is affecting your audio, you will have no problem using it. If I ask what the normalize effect does, you would say it adjusts the volume level. What is the job of the compressor effect? The compressor effect reduces dynamic range. Dynamic range is the technical term, but basically means the loudness gap between louder and softer talks. If this gap is large, it becomes difficult to listen to some parts of the audio comfortably. A compressor effect reduces that gap, and the overall audio becomes easier to listen to. So what exactly does a compressor do? When you look at a waveform, you'll notice that some sections are taller. These are the louder parts of your audio, and some sections are shorter. These are the quieter parts. The difference between the loudest and quietest parts is called the dynamic range. A compressor reduces this dynamic range. In other words, it makes the loud parts a little quieter and the quiet parts a little louder, so the overall sound feels more even. When you reduce the dynamic range, the audio often sounds louder and more consistent to the listener. It's important to keep in mind that judging dynamic range just by looking at the waveform isn't always accurate. Visually, you can sometimes guess, but there's a better way to measure it precisely, and that's by using the Amplitude Statistics window. To do that, go to the Window menu, select Amplitude Statistics, and then click Scan. This will analyze the entire piece of audio and give you several readings. For compression purposes, the value we care about most is the total RMS amplitude. RMS is a measure of the average loudness of your audio. For professional voice work, especially audiobooks, the RMS should be between -18 and -23 decibels. This is the industry standard for clear, comfortable listening, and it's also the range required by platforms like ACX. Please note that the higher the RMS, the louder the audio overall. In our example, the RMS reading is -23.19 decibels, and the peak amplitude is -3 decibels. The total RMS falls behind the expected range. We need to increase it, and we can do it using the compressor effect. Please note that the peak should be -3, but the RMS has to be increased. That means you have to increase the RMS without increasing the peak, and that's where a compressor effect shines. Usually, the peak and RMS have a linear connection. If you increase the peak, the RMS will also increase. But if I have to make this audio ACX standard, I cannot increase the peak, it is already -3 decibels. I can use the compressor effect to increase the RMS without increasing the peak. If you understand the purpose, you will never have trouble using the compressor effect the right way. Now let's actually apply the compression. Go to Effect, then Amplitude and Compression, and choose Dynamics. There are several compressor effects, but the Dynamics is the easiest to configure. First, set it back to the default preset so you're starting from scratch. In the Dynamics effect window, you'll see three main options: Autogate, Compressor, and Expander. For this process, we only need the compressor. Leave Autogate and Expander unchecked. A good way to begin is to select the Soft Compression preset. This sets a basic configuration so you can focus on the two most important controls: threshold and ratio. When you choose the Soft Compression preset, the other settings are okay for voice recording. The threshold is the point at which the compressor starts to work. Currently, it is -12.3 decibels. The parts of the waveform that cross -12.3 decibels will be compressed. If I change the threshold to -13.6 decibels, then parts of the waveform crossing -13.6 decibels will be compressed. So you get the point. Whatever threshold I set, audio levels above that will be compressed. The lower the threshold you set, the more of the waveform will get into the range of compression. Usually, a threshold between -10 to -15 works okay most of the time for voice recording. The ratio determines how much compression is applied once the audio passes that threshold. A ratio of 2 to 1 means that for every 2 decibels above the threshold, the output will only increase by 1 decibel. If you lower the threshold, more of your audio will be affected by compression. If you increase the ratio, the more the audio will be compressed. For most voice work, a ratio between 2 to 1 and 4 to 1 is ideal. Too much compression, however, can make your audio sound unnatural or lifeless. In our example, the audio is already quite uniform, so we don't need a heavy setting. But if you were processing audio with big volume jumps, say some parts are much louder than others, you might lower the threshold and increase the ratio to smooth things out. I will apply these settings and check how it is affecting the RMS value. Once you apply the compression, you'll notice that the waveform's tallest peaks are now closer in size to the quieter parts. This means the dynamic range has been reduced. But compression can also change your peak amplitude, which is why it's important to normalize afterward. You can see the peak is now around -6, which was -3 decibels before. The RMS has increased, but we can compare correctly when we set the peak to -3 decibels again. To normalize to -3 decibels, go to the Favorites menu and choose Normalize to -3 decibels. Please note that when you use a compressor effect, you should use a normalize effect immediately after to get a true measure of RMS. I will then go to Amplitude Statistics to scan the audio again. This time, you should see the peak amplitude at -3, and the RMS is closer to something like -18.8 decibels. This tells us the audio is now louder and more balanced. If the audio feels too loud after compression, you have to undo the compressor effect and adjust the compressor a bit differently. You can adjust it by raising the threshold or lowering the ratio. On the other hand, if you need stronger compression, you can lower the threshold and raise the ratio. It's a matter of listening carefully and adjusting until you're happy with the sound. Once you get comfortable with this basic method, you can experiment with the other compressor options, like the multi-band compressor, which lets you compress different frequency ranges separately for even finer control. That's how you use the compressor to manage your audio's loudness. For now, I would recommend that you follow this effect sequence: normalize, compressor, normalize. You will then feel how your audio really sounds at different RMS levels and have a better idea of audio quality. However, the ideal processing workflow is like this: normalize, noise reduction, EQ, compressor, and normalize. If you want to get all the effect configuration with screenshots, you can look in this PDF file. You will get it from the last link in the description. If you want a step-by-step video on how to make your sound professional and better, click the video on the screen.